So welcome to our second lesson in 2.1, the internal assessment for Level 2 NCEA Physics, in nonlinear relationship analysis. So in terms of presenting data, before we start creating graphs, we have to consider how we're going to be combining our measurements. Okay, so remember our significant figure rules. For adding and subtracting significant figures, the answer has to have the same unit places as the smallest unit place for the variables. And for multiplying and dividing significant figures, the answer has to have the same number of significant figures as the least accurate number, okay, the smallest number of significant figures for the variable. And then when taking measurements, choose the best measuring instrument. Okay, so for example, if you're measuring the diameter of a marble, then you'd use a micrometer or a vernier caliper rather than a meter ruler. Know how to use the instrument as well, especially for those two pieces of equipment. Know how to increase the accuracy of that particular piece of equipment, and state the appropriate SI units when you're using that particular piece of equipment. Need a table. So on the first lesson, when you're collecting the data, make sure you have a table set up that has enough columns to handle all the data, the appropriate units for the variables, multiple readings of your independent and dependent variable, the average for the dependent variable, and variables row recorded with the appropriate significant figure. And also for your table, the anomalous results are removed or at least highlighted. Notice also that your table requires to have the process data which you need for the second graph. Okay? And you need to provide examples of how your data that you've used in the table has been processed. So for the second graph, what we're actually aiming for is this linear relationship where y is proportional to x. So you want to find the gradient of that, which will assist you in working out the relationship between your two variables. So it's important when you plot your first graph, you understand what the graph shape actually represents. Okay, so if you get a graph shape like this for your first plot, it means that you've got a y is proportional to x squared relationship, an exponential relationship, which means that if you plot y against x squared, you'll get a straight line for your second plot. This is an example of an inverse relationship, so y is proportional to 1 over x. Okay, so if you plot y against 1 over x squared, 1 over x, you'll get a linear relationship. And then we have this relationship here, which is a square root relationship, which is y is proportional to the square root of x. So again, if you for the second plot, you will need to plot y against square root of x to get a straight line relationship. And if you get this for your first graph, it means that your relationship is y is proportional to 1 over x squared. Okay, so it's important when you look at your equation that you're given on the sheet for the assessment, look at the equation and you see which one is going to go on the y-axis and which one is going to go on the x-axis. So if the equation is going to be y equals x, or mx, that means that the y will of course be on that. You'll plot the value which is on the left-hand side on the y-axis and the value which is on the right-hand side on the x-axis. So in terms of your graphs, these are the expectations. You need to have, for both of your graphs, a title describing the two variables involved in your two graphs. In both cases, the axes have to be labeled with the quantity and unit. You have to use an appropriate scale for your variables on both the x and y axis, and also they have to be equidistant, and the graph has to be sufficiently large if you're going to be hand plotted. The points are plotted as crosses, and any anomalies are identified with a circle around them, as you see on the image. And if the graph is nonlinear, which we will have for the first graph, the data needs to be processed to create one, which is your second graph. And in both cases, they need a line of best fit. Okay, so in the second graph, there will be a linear line, straight line. In the first graph, that might be a curve, more likely will be a curve. Finally, for analyzing the graph, you need to calculate the gradient, which is going to be the change in the y variable over the change in the x variable. If you're using a hand plotted graph, that has to be about 2/3 the size of your line of best fit. And the unit's going to be the units of y divided by the units of x. And the intercept will be the value which cuts the y-axis when x equals 0, and the unit for the x-intercept, or the y-intercept, will be the units of the y-axis, and thus the equation that you'll have to end up at the end will be y equals mx plus b, where m is the gradient and b is the intercept on the y-axis.